Welcome in, my math party people. Anderson here, your math coach. And in this video, we're gonna get started on learning the laws of exponents, okay? So long story short, what we're doing here is we're gonna be learning how to multiply when it comes to different variables or same variables, numbers, all that good stuff, and how to handle those situations, especially their exponents. So let's just go ahead and dive on in. Let me just show you a couple of examples here. So before I get into this one up here, just wanna make sure that you understand the main plane rule. Basically, when you're multiplying powers that have the same base, you will add their exponents. So let me go ahead and show you how that works. So for example, and go ahead and write that down again. If you're multiplying powers with the same base, so let's say you have x squared times x to the power of 3. Well, what you do is you simply go ahead and add those exponents, and you'll have x to the power of 2 plus 3, which is the same thing as saying x to the power of 5. And so that's really it, my math party people, to start things off. Now, I want to go ahead and show you why this works before we actually get into it, because remember, it's not about getting a question right or getting it wrong. It's about understanding the why, and that's how you're going to grow way, way, way faster. So my math party people, let me show you why this works really quick, and then we'll get into these examples, and we're going to get at least 10, 15 problems in. I got your back. So here we go. So the reason that this works is because of the following very, very straightforward reason. First of all, I think we can all understand and appreciate that x squared, what that means is x times x, right? Right? When you're saying to the power of 2, the exponent of 2, that means you're multiplying that number by itself 2 times. Okay. Now, let's go ahead and say we take a look at x to the power of 3. What does that mean? Well, when we have x to the power of 3, well, all that is you're saying, hey, I have, now 3 x's being multiplied by themselves. And remember, they were already being multiplied. So with that said, you're now going to have 3 more x's being multiplied. And guess what, my math party people? How many x's do you see right there? How many x's do you see being multiplied together? We see a total of 5 now. And that's why you simply take the shortcut and add those exponents, because what you're looking at is saying, hey, I have 5 x's being multiplied together. And that's why it's x to the power of 5. Because remember, that exponent just tells you how many times you're multiplying that base by itself. And that's really it. That's why you add those exponents. But remember this, if you have something to the effect of, let's say, x squared times y cubed, well, that's going to stay x squared y cubed. That does not change. Because remember, you don't have the same base. X is the base here, y is the base there. Those are not the same bases. Remember this, again, you need to have the same base. When you're multiplying powers that have the same base, add their exponents. And here is your regularly scheduled announcement, my party people. Remember guys, I host a free class every single week and more classes beyond that. So make sure to check the group tutoring schedule so you know when the classes are, when you can expect to see me live, so you can raise your score and get that job you want. So click there to see the schedule, and let's keep getting back to the YouTube video right over here. So, without further ado, let's go ahead and practice this idea. Let's go ahead and put it into practice here. Let's have a good time. So, here's how I like to take care of things. First, I like to take care of any regular numbers that I see that are being multiplied. On top of that, once you're done, then go into the letters. And if you want to go alphabetical order, hey, that works. So here we go. So we have here the regular numbers being 8 and 9. 8 times 9 is going to be 72. And then we have ourselves over here, v cubed and v to the power of 6. So v cubed times v to the power of 6, well, again, we're just going to add those exponents nice and easy, because you have 3 v's being multiplied here, 6 v's being multiplied there, so that's a total of 9 total v's being multiplied. And so that'll be 72v to the power of 9. And that's why here, D would be the correct answer. And so we're going to go through plenty of examples here. So hang tight, because remember, as we go through, I'm going to show you more difficult examples. So let's go ahead and dive into the next one over here. And we're going to go through a couple of these easy ones, these basic ones. But again, watch the whole video so you can see the more complicated ones with more variables being involved. So here we go. We have 4n cubed multiplied by 5n to the power of 5. Again, like I said before, first things first, take care of those regular old numbers. 4 times 5. And if you're confused as to why we can mix the 4 and the 5, even though there's an n cubed in the way, remember this. 1 times 2 times 3 times 4 my party people, that's the same thing as saying 1 times 3 times 2 times 4. Remember that when you're multiplying a bunch of things straight up, you can rearrange the order that you multiply them. So you're good. You don't have to really worry about that. You're fine. And so I can go ahead and multiply in any which order I want. 4 times 5, that's going to give me 20. And then we have the n to the power of 3 multiplied by n to the power of 5. Again, we're going to add those exponents, giving us n to the power of 8. And that's c right there. So again, let me go through a couple more of these fundamentals, a couple more of these basics, and then we're going to dial it up here with some more difficult problems coming right up. So here, notice how this one's a little different. Yeah, we're still dealing with n, but notice how there's no exponent right here on this n. What are we supposed to do, right? So remember this. First of all, take care of the numbers. Don't let yourself get confused. We have 2 multiplied by 8, and that's going to give us 16. So let's go ahead and write that out over here. But now up next, what happens with those n's again? Well, remember this. When you have n squared, let me use green here, n squared times n, well, what exponent is right there? Like, if you don't see an exponent, what is it? Remember this, write this down. If you don't see an exponent, the exponent is always 1. It's always 1. If you don't see it, it's always 1. Because remember, there's just one of those n's being multiplied. Remember, what the exponent means is how many of those variables or terms are being multiplied by itself. And so here, if you just see n, well, that's just one n. One of those n's being multiplied by itself. And so you can treat that as an exponent of 1. You should always do that because you have 2 of these n's being multiplied with another n, and that's going to give you 3 n's being multiplied together, which will be written as n cubed. So we have 16n cubed, and we are good. So we're going to go through one more of these fundamentals here, and then we're going to move forward into multiple variables. So we have an x and a y, or m and an n. Let's go ahead and get into it right after this one. So first off here, taking care of business, 7 times 9, that's going to give us what? 63. So nice and easy, there we are. And then lastly, we see here, just like in the previous problem, we have an x by itself, but then we have x to the power of 10. So again, you are adding those exponents because you're seeing how many times that variable or base is being multiplied total. So you have 1 there with the x by itself, then you have 10 of them with the x to the power of 10. The total is going to be 11 of those x's being multiplied, and the best way to write that is x to the power of 11, because you simply add those exponents. And there we have it, 63x to the power of 11, and we are good. But like I promised, we are going to go through more and more complicated problems here. So let's go ahead and get into this next set where I'm going to show you again, what if we have more than one variable? So let's go ahead and start over here with number 51. Let's go ahead and get into it here. So again, more than one variable, what happens? Remember, you can only combine the exponents when you're multiplying when you have the same base. So we have a u over here and a v over there. Those are not going to combine. The u's will combine with the u's. The v's will combine with the v's. Make sure we understand that. And so here, my math party people, here we go. We're going to go ahead and first pay attention to the numbers. Again, nice, calm, cool, and collected. Deal with the numbers first. 3 times 10 sounds good. That'll be 30. Then we deal with the other variables and try to do it in alphabetical order. So u comes first, so I'll deal with a u cubed and u to the power of 4. What is that going to give us? Well, that'll end up being u to the power of 3 plus 4, which is going to be 7. I'll write that in a moment, but I'm going to take it nice and slow for us. And then we have the v over here, right over here in red, v to the power of 8, v to the power of 7. So we'll write that over here as v to the power of 8 plus 7. Nice and easy here. And then just go ahead and simplify, finish this off. So we have 30 u to the power of 7, because 3 plus 4 is 7, and v to the power of 15, because 8 plus 7 is 15. And there it is, my math particle. All good, all set. Let's go ahead and highlight that, and that's going to be right over here. And let's keep it going here. Let's go ahead and do perhaps 6 to 8 more, and let's have a good time. So up next we have 3y to the power of 6 times 5 times x times y to the power of 10. Again, remember, you can rearrange all these multiplications to see it the right way if you want to. If you need to see it rearranged, the way that you'll go ahead and see it is, look, you have your regular numbers in red, I'll have my x in blue, and my y is in green. And so the way that I would rewrite this, my math party people, is 3 times 5 times x times y to the power of 6 times y to the power of 10. If you wanted to rearrange it to see it in that way, remember, 1 times 2 times 3, you can multiply the 3 first before the 2. It doesn't matter, you're still going to get the same answer. And so boom, you can get that done right there. And it's me again, your Coach Anderson. Look, you're doing these problems right here on YouTube, but I want you to join me for a live class that's free once a week. I do this because I want to help other people succeed, just like you. So if you want to raise your score, sign up for my free classes once a week. They're hosted on Zoom. And on top of that, you'll get my free practice test that comes with video solutions so you can learn from every mistake. So there's no reason not to sign up. So go ahead, get off your butt, sign up here, the link there, somewhere over here. Figure it out, but sign up, and I'll see you in the next class, my ASVAB party people. Let's get back to the problem. And then 3 times 5, that'll give us 15. After that, we just have the x. And notice there's no other x, so it doesn't mingle with anything else. And then lastly, we'll see that we have y to the power of 6 times y to the power of 10. And so when we take care of that, you add those exponents, because you now have 6 plus 10 y's being multiplied, so that's 16. Y to the power of 16. And there we have it, my math party people. The correct answer here is listed as D, although I would say that we would want to see this in alphabetical order whenever we can. So you can have 15y to the power of 16 times x, or 15 times x times y to the power of 16. It'll be the same thing each and every time. So let's go and get through a couple more here, my party people. Let's go ahead and grab a couple here. So let's take a look at this interesting one here. What do you notice about this one that's a little different? You may have noticed that we have an x that's to the power of 0. What is a base to the power of 0? What is that going to be? That's going to be 1. That's going to be 1. So x to the power of 0 equals 1. Anything to the power of 0 equals 1. Okay, my party people, write that down as well. You know, you could have 7 to the power of 0, that's 1. You could have 10 to the power of 0, that's 1. Anything to the power of 0 is 1. Flat out. So, with that said, my math party people, here we go. This right here, that x to the power of 0, we can just go ahead and get rid of it. Because if you make that a 1, well, guess what? 9 times 1 is going to be 1. So you can treat it that way. Or when you go ahead and add those exponents, notice that 0 plus 9 is going to stay 9. So either way, that x to the power of 0 is just kind of fade away. There's nothing really going on there. Anything to the power of 0 is 1. That's going to come back later on, so pay attention to that rule. But long story short, let's take care of our numbers. 9 times 5, what's that going to be? 45. From there, we're going to have ourselves x to the power of 0 times x to the power of 9. 0 plus 9 is going to be 9. And lastly, we have ourselves over here, y to the power of 6, y to the power of 8, those being multiplied. And so we'll have y to the power of 6 plus 8, which is 14. And there we have that. And so, booyah, we take a look over here. Our answer will be C. Let's keep it going here. Number 54, let's go, let's go, let's go. And remember, at any point, go ahead and pause and then keep going, all right? And also, if you're in the course of the program, remember, what you have next is you're going to have those worksheets ready for you to try out, specifically for the product law. Then on top of that, you'll have your speed drills ready to go so you can continue practicing nice and easily all the way through. So 54, here we go, my math party people. We have 3x to the power of 5, y to the 7th times x to the power of 4. Want to take a look at my regular old numbers? I just have a 3. Nothing else to be really worrying about. On top of that, we have x to the power of 5, x to the power of 4. So those will combine because they have the same base. They are the same x as the base. And then we have y to the power of 7. All right, cool. So with that, we leave the 3 as is. And then x to the power of 5 times x to the power of 4, that'll be x to the power of 9. Because again, the rule is you will add those exponents. And then lastly, that y to the power of 7 doesn't have anything with it. So it'll just stay right there, nice and easy, nothing changes. And so the final answer here will be D, 3x to the 9th, y to the 7th. Right on. And so let's see if we can find another crazy problem here. Let's say we're taking a look at 56. Here's the thing. When you're taking a look at 56, notice that we have x to the power of 0, x to the power of 0. those will both simplify to just be 1. And so if we write a new problem out, it'll simply be 6y squared times 8y to the 9th. Again, those x to the power of zeros, they're gone. Anything to the power of 0 is just going to be 1. And since you're multiplying by a 6 and an 8 or whatever, the 1 multiplied by 6 is not going to change anything at all, right? Cool. So with that, here we go. We have 6 times 8. And that's going to go ahead and give us 48. And then we see that we have y squared and y to the power of 9. And that's going to be y to the power of 11 because 2 plus 9 is 11. And there we have it. All set there. Our final answer should be 48y to the power of 11. And we're good. So let's see if we can find another crazy one. I think we should be able to find another crazy one if we keep searching here long enough. Let's see. Ooh, this looks pretty good over here. This looks pretty heinous. Let's go ahead and take a look at number 78 here. A more difficult one even so. So notice that we have 3 variables that we're dealing with now. As always, keep it calm, cool, and collected. We're going to start off with the regular old numbers. Then we can work alphabetically with those variables. Here we go. So we have ourselves with the regular old numbers, we have 6 multiplied by 3. 6 multiplied by 3 is going to give me 18. From there, let's see what we have alphabetically. Well, we'll have m to the power of 10, m to the power of 10. So if we have both m's being to the power of 10, that means that we're going to do 10 plus 10 for the exponent, making it m to the power of 20. And again, you can only do this because you have the same base being multiplied. M is the same base for both. So that'll be m to the power of now 20. Really quick ASVAB party people. While we continue this video, if you're enjoying it, which at this point if you're watching, I know you are, please remember to like this video, comment your favorite part, and subscribe to the channel. That way you can help us spread the word about helping people raise their ASVAB scores just like we are. Let's keep getting the job done. Let's get back to the video. Appreciate you. From there, alphabetically, we'll go to n. We have n squared, n cubed. So you have the same base. We can apply the rule. 2 plus 3 is 5, so we have n to the power of 5. And then lastly, what I see here is we have, I'll use purple, p to the power of 8, and then we simply have a p there. Be very careful. A lot of the times when you don't see an exponent, you might be tempted to say, hey, the exponent for p is 10, which is not true. If you don't see an exponent directly on that piece, then there is an exponent of 1. It's not going to take the exponent of the thing next to it. It just doesn't have an exponent shown, but it's going to be 1. It's not 10. 10 is with the n. So with that said, we have p to the power of 8, p to the power of 1, or just one of those p's. So now we have 8 p's being multiplied, 1 p being multiplied. That's a 9 total p's being multiplied. And so that'll be p to the power of 9, making D our final correct answer. Just like that. And now let's see if we can do another one, my party people. Let's see if we have another one here that's even crazier than the last one. If we wanted to get even crazier, we absolutely could. We can try something like, let's say this one out, 94. Let's go. We have a lot going on here, don't we, right? We have a lot going on. So pause the video if you want to try this one out. But long story short, my party people, just like always, focus on your numbers, then alphabetically go one variable at a time. Let's try it out here. So we have ourselves our regular row numbers being 6 times nothing else. So 6 times 6 gives me 36. Next up, I notice I have M, P, and Q. Alphabetically, it's already set up for me. So I'll go ahead and start off with the M squared. And then I don't see M anywhere else. So I'm just going to go ahead and rewrite it. There's nothing else being multiplied by the M squared. So you still have M squared. Next up, we have P to the power of 8, P to the power of 7, and just P. Again, that is not P to the power of 9. That's just going to be P. So we're still going to have 8 plus 7 plus 1, which will give us 16. 8 plus 7 is 15, plus 1 is 16. Remember, that's an exponent of 1. So P to the power of 16. From there, we have Q to the power of 7. I'll use blue here. Q to the power of 7, Q to the power of 4, Q to the power of 9. And again, they're all being multiplied, so you'll simply add all of their exponents. And so what we have, my party people, 7 plus 4 is 11, plus 9 is 20. And so we have right there Q to the power of 20, and that's what makes answer choice D the correct answer. And there you have it, my math party people. I really do hope you enjoyed this video because, we have to get to know this rule here. Then we're moving on into division. Then we're going to power of power laws and also negatives. And then we're going to have mixed practice at the end. That way you can bring it all together and be certain that you have absolutely mastered this topic. And so, with that said, my math party people, I'm your coach, Anderson. Let's go ahead and move forward into that worksheet now. And from there, go ahead and try those speed drills out to confirm that you're all good no matter what, and you can move forward the right way. If you have any questions, you know how to reach me. Let's go ahead and keep raising that score, and let's have a good time. I'll see you soon. And before you go, if you like what you saw and you want to raise your score with thousands of practice problems just like that, so you can lower that test anxiety, raise that confidence, go to this link right here to check out the full program. There's a video that shows you exactly how it works, but you're going to get lessons, guided practice, worksheets, speed drills, and everything that you need to feel supported from day one all the way until you pass. Again, I'm Coach Anderson, and I'll see you soon.